I think it's time to start. So, as I said, I'm not Steve. My name is Anastasia Kazakova. I'm from JetBrains. Actually, Steve had to leave for some personal reasons, so we did a switch for the talk to have some more time for us to find someone for tomorrow. So my talk was planned for tomorrow, actually, so it switched for today. So thank you for coming here, especially if you actually came for my talk. I really appreciate that. So let me briefly just introduce myself for those who don't know. So I work in JetBrains. I'm responsible for our C++ tools as product marketing manager. Before that, I spent 8 years in various embedded networking development, doing a bunch of C and C++ on various embedded devices. Kind of very interesting stuff, but then I decided to switch a little bit further from actual development to something related to that. I live in St. Petersburg in Russia, and if you by chance there, I have a user group there, a C++ user group, obviously. It's kind of very big and very welcoming community, so if you're there, for example, for C++ Russia, which is the biggest C++ conference in Russia, you're very welcome to come to my user group. So you can find us on meetup.com and find a meeting close to your dates there, and I'll be very happy to see you there. And if you decide to make a talk, for sure, just ping me. So the talk is called C++ ecosystem for better, for worse. There is some quote from the marriage vow. So we're all married to C++, actually. And that's our ecosystem. We can like it or not, but we have to do something in it and to do C++ development in this ecosystem. So in this talk, that's not a very practical talk. So I can promise you that you learn any new feature or how to use something. No, that's not about it. That's about what's the current state. And so this is the actual agenda. So we're going to talk about the current state of C++ development. So I plan to overview this current state and to use some information that we gathered from various independent sources, various surveys. So we'll try to explore which language features and techniques are used across these areas that are most popular in terms of C++, the biggest areas for C++ development. And we'll try to identify the key evolution paths for this ecosystem. So we'll check how developers are using unit testing and code analysis with some statistics data. So there'll be a lot of statistics in this talk, lots of nice infographics. And we'll try to understand if it helps the transition to the newer standards or if there are some issues with that. And we'll briefly, in the very end, we'll try to understand if the committee and those who do the tooling, like us, the vendors, can help the developers to transition to newer standards. There is a disclaimer here. I might be wrong. I will be showing some statistics data, and you know that statistics is always wrong. But again, I'll try to explain why the data is more or less true and general. I'll do my best, but I might be wrong here again. Then I will be using some information which actually came from some interviews with the people from different areas. So I was from embedded areas, so I worked there. So I more or less know what's going on in the embedded. For other areas, I mostly talk to the people who are working there. They also might be wrong. So it might go in a different way for you working in this particular area. That's totally fine. And I'm here to discuss it with you. So if you would like to drop some new ideas and to share your thoughts on what I'm going to talk here, I'm very welcome to all of them. So talking about the basis for my infographics and for my statistics, so this is the State of Developer Ecosystem Survey we run in JetBrains. We started it in the end of 2016. So we ran it for 3 times already, 17, 18, and 19. 17 and 18 are already available with the nice infographics across all languages, technologies. The raw data is also available, so you can grab it and actually calculate any infographics you like based on that. 19 is under processing now, so it's not available. We closed the survey already, just maybe a month ago, but it's still under processing, and I would expect the infographics in maybe a month or so, and the raw data in a couple of months after that, because we still need to anonymize it properly and to provide it correctly. So I'll try to explain why we think that our survey actually covers the community. So we have a huge actually research department who is responsible for doing all these surveys. So, and they are trying to use all the different algorithms that are there to handle the data to provide the proper surveys. So the respondents who were replying to this survey, they're not only our users. That's a very important disclaimer here. So we were trying to push the survey to the outer world. So of course, there are many of our users subscribed to our channels and blogs and Twitters who saw the announcement and filled the survey. That's kind of natural. But we tried to remove and actually to reduce the branding as much as possible from the survey and to push it to the outer worlds via different advertising channels. So we used Twitter, we used Facebook, we used Google AdWords. So, and we were providing some prizes, which we raffled among those who filled the survey so that the people have like some additional reason to fill it actually. Hopefully they were not filling only for that reason, but to share some valuable information with us. But since it's like quite long survey, we needed something to praise our users. So to avoid to be biased by English-speaking countries, we translated the survey into 6 languages, which included Chinese and some other languages. And the goal for that was very clear. We know from different surveys that like 70% of the developers in different languages in the world are located in some fixed number of countries. So there is a fixed list of countries where all these developers are actually living and working. And so our goal was to cover these countries as much as possible so that we have enough representative from each country. And later I will show you the distribution and some information about the general audience who was filling the survey for C++ part. So we tried, so as we see, like most of the respondents are usually like either fully employed or students. So, and the thing that I was not doing when preparing these infographics, but that will affect the final results that will be published officially by JetBrains, is the weighting. So I'm here not doing the weighting, I'm just taking the raw data and processing it. The research department will be doing the weighting because they have some numbers on what is the approximate number of students and developers in each country, and they will try to balance it. I checked the results from the last year, like weighted and not weighted, just to be sure that the trends are still kept, and that's true. So the numbers, the actual percents, will be a little bit different, so you can expect that. But the general trends are actually kept, so we're more or less fine. So if we're talking in particular about C++, so we had 2 questions to identify C++ and C developers in our survey. One of which is like list all languages you're actually using, and one of which is list 3 primary programming languages you are using. So I will be collecting the data for this primary group. So actual numbers are as follows. So for those who fill C or C++ in the first question, like using C or C++ in the last year, it's like 5,500 of people. So for those who used C, it's actually 3.5. For those who use C++, it's actually 4,000. And the primary C++ group, it's not that big, it's just 1,500, like to be more accurate, like 1,698. But these are the people who marked C++ as their primary language. So these are the people who actually answered all the questions using this C++ experience they have on their everyday basis. So last year, for primary C++ groups, we get smaller, bigger numbers. We get more than 2,000. This year, actually, the situation was a little bit more different because the GDPR came in action last year, and we had to drop all our databases we had for years, collecting different information about our users. So we tried to reach them, but naturally some numbers actually lowered down from the last year. But I really like this group with primary C++ selected because that means that this group actually knows what they're doing in C++. They're doing it every day, and they're more or less answering the questions and giving me the information I'm interested in. So I will be also using some information from C++ Foundation survey, which was run in 2018, so a year ago. And the number of C++ developers there who use the C++ at work is 2,884. So, and I would say that this is This is a little bit different community because the survey was promoted mostly on foundation sites. So there were some people who were retweeting, but still, so it was not pushed per different channels, and it was run in English language only. But still, I see that the results are more or less correlate. So I'm pretty much sure that the results that C++ Foundation actually collected, I checked them in comparison to the developer ecosystem survey we ran a year ago, and they were more or less the same, some slightly differences, but I'm pretty much sure that both of the surveys show the correct results. So let's talk about the audience, this primary C++ group. Who are they, what they are doing, and let's learn a little bit about them and understand this audience. So this is the platform distribution. So as you can see, like most of these developers are like even 70% like Unix and Linux. So you see that the sum is more than 100%. That's fine because they can select more than one answer. And so that will be true for all our questions. We try not to keep them just to select one answer, but several answers. So Windows and Linux, the most two popular platforms, but that's true for general C++. So we did, the first survey we did on C++, the first research, was in 2013, when we did the research before starting all our C++ tools, because we just realized that we can do that, but we need to learn more about the community. And we did these distributions at that time, and it actually correlates with all these distributions. So this any2 group in the very end is actually those who are using both platforms at a time, and most of the answers in these two groups is actually Windows and Linux. So macOS is not that popular in terms of C++, but still there are like nearly 10% of those who use all three. So at least that's the audience we get here. Going next, some areas of development. So I should comment on the names we have here in the areas. So it's missing one very big area, like financial and banking, just because the distribution, the set of answers here in this question was a little bit different from what I actually want, so the financial developers were more or less distributed between other groups. But this is how the distribution of the developers who filled our survey looks like for us. So, and I'm pretty much happy that I got quite many answers from embedded and games developers, the two first columns, so embedded, and here are the games. ML, there is machine learning. So if you're still guessing, and yeah, so the third area missing directly here, but spread among others, is actually financial and trading. Employment status, as I said, most of the people who are filling our survey are either students or fully employed. So this more or less affects, and I will be showing some distributions per employment group, especially for the standards, which is kind of different and which is important. So, and in terms of those who are filling the survey, so for us, employment status actually is important, and we're not targeted only on those who do the full-time development in C++ students. These people are also a very interesting group because these are the future of the community. So what they learn is actually what we'll be using in like 10 years. So it's interesting to see what they're actually using right now because that will affect our C++ future in some time. So yeah, the big question, and there will be a couple of slides which I called throwing a ball. That means that I will try to ask you before I show some data, some questions. So the question here is like, who follows and uses the latest available official standard in their everyday production development? Okay. I think I know all the people who are using that. Yeah, so this is the answer from the community we actually questioned. So not a big surprise. However, while submitting the talk to ACCU in fall, I was expecting a less number of people on C++ 17. Like, honestly, I was looking at the results from the last year and from the year before. I was saying like, okay, no one will be using C++ 17 when I'll be doing an ACCU talk. But when I opened the results like 2 weeks ago, and I found out like 35%, nearly more, nearly 36 of people at C++70. That's great. I'm really happy to see that. So, but still, you can just see that quite many people are still on pre-C++11, and a very huge group on C++11, actually. Okay. Let's compare with the last year, because I said that I was expecting it to be much worse. So the blue is the 2018, the green is 2019. And so you can see how the groups are actually different. So there is a small decrease for these pre-C++11 groups. That's good. But if you look at C++11, it's nearly the same. So it's nearly stayed here. But yeah, here we finally grows. This is good, actually. This is a big growth. And this might be connected to the fact that, yes, so we're like C++17 is like it's signed, it's like we all trying to finalize the C++20 nowadays, and it's nearly the feature freeze for C++20, and finally the people are starting to use C++17. Yes, Herb?
Do you happen to know whether that's mostly people going directly from the left-hand side and jumping to 14 and 17, versus whether it's pulled through?
That's a very good question. So the question from Herb was like where they're moving from. I will come to that in a couple of slides. Just be patient. So first of all, I'm like when I opened that, I compared that to the C++ Foundation survey year, which was held a year ago. So more or less the same. Like the C++ Foundation has this like big green line for all standards, but that's fine because the question actually sounded like which language standard you're allowed to use. So like people are allowed to use the old standards, but probably they are still using something newer because they're still allowed to use something else. So I checked that just because I wanted to be sure that it's more or less fine and it correlates. And to me, it seems that more or less, yes. I have one more data for the standard distribution, and that's a very old data. And I want actually to show it here. To show you one like very important thing. So this what we gathered from our research in 2012, 2013 when we started our C++ tools. So we wanted to know like what people are actually using. At that time we were very naive. We were mixing C and C++ standards into one question. Now we understand that you should not do that. No way. So but like we estimated the number of C++ developers quite correctly at the time. So at that year we got the number of 4.4 million C++ developers in the world. It was lately confirmed by other researchers from other companies and other sources. So we more or less believe that's true. And I would say that I see here that back then we had like 44% of C++11 developers. And at that time, that was mostly the newest standard, like C++14 was not in place when we were collecting the research. And so yeah, it's now grown up to nearly 17, and many people are still there. But like the interesting fact is this C++98 was the same 40%. They're still there, these people using C++98. So maybe the same people, I'm not sure, like at least the percent shows something very similar. So yeah, but to compare, like C++03 has actually fallen down, but not the C++98. That's probably the most stable standard for many developers. Okay, so now let's analyze some slices. So let's analyze how these results are actually distributed among different groups of developers. So what we can see here is we can see per platform distribution for the standards. So maybe it depends on the platform people are working on. Compiler distribution, obviously, because you always depend on your compiler. Area of development, and employment group. So let's see if any of these factors actually affects the results. Come on, move forward. Per platform distribution. So in general, it's very similar. like all the trends are the same. So if you would like to compare some platforms, you would see that here is the macOS with the lowest number of C++17. Here are the others, very similar for Windows and Linux actually. So Linux is like trending in C++11, but I would expect that, at least being from embedded development, I would expect that. But we'll come to that a little bit later. So okay, let's try another factor. Let's try another slice. Let's try compiler. So are they different? But they're very similar again. So there are still some differences, like for Clang, you might see the better usage of C++17, but on the rest side, it's more or less the same distribution per compiler. Even though the compilers have different speed of supporting the features, have different flags, have different directions, so they start from different parts of the standards, still, the people who are using the compiler, they're mostly on the same level, on the same trend. Okay, let's see the distribution by the areas of development finally. I kind of expected Pike for embedded at C++11. I'm not surprised here. I will explain it in more details when we come to particular discussion of some top areas for C++. Libraries and frameworks, I guess it's also not surprised that they have better adoption of C++17 because like when you're starting a new library, you can do that. And there are many libraries created right now using the modern standards. You're fine with that. So yeah, in terms of the other results, there are some slightly differences here, but more or less the same. And like employment groups. And this is the difference which I see if you compare the full employment, like in partial employment with the students. Like the students are more brave, and that's fine. Because when they learn the features, they can use, like when they learn the language, when they learn programming, they can use newer features. They're not limited by any factor. They're not limited quite often by like legacy code, the company rules. And so they can adapt the C++17 more actively, and they can move to the new standards faster. So other groups are probably limited more. So they have like some worse adoption of the like C++17, for example. But again, like the trend is kept across all the groups. There is another graph for this kind of first slice. Is I took actually two groups, students and fully employed people, and as they are the biggest groups for like in terms of respondents for other survey, and tried to see like in each standard version, how many of this group is actually represented by our survey. And so, yeah, here we have, like, you can see that the blue, which comes for student, for C++17 is actually nearly 40%. So I think like the percent is bigger than for other standards. So, and that's actually what we saw on the previous graph. So I removed the rest of the groups here just because like they're too little, and you see that these two groups nearly form the 100%, so the others are just a very small amount. Okay, so the question from Herb was about upgrading. Now we're coming to upgrading. So we have two questions regarding the upgrading in our survey. One of which is, are you going to upgrade during the next year to a new standard? And the other question is actually to which one? So this is regarding the general question, the first question about plans to upgrade. So you can see that actually quite many people, more than half of the respondents, are not planning to upgrade at all to a new standard in 1 year from now. So they don't have these plans by many reasons. It's like 53%. If I'm not mistaken, it's something very similar to what we had last year. But quite many people here are actually planning to upgrade to C++17. So you can see here, it's nearly 40%. This is much bigger than last year, nearly twice bigger. So, and this is actually good. Probably people were waiting for like better adoption by other people, and now they realize that they can start. They see some good reasons to upgrade, and they're actually planning to do so. I also made this infographics about where the people are gonna transition in the next year from where they are now. So you can see like the all respondents part here. That's what we just saw previously. And then all the standards. So like obviously like we didn't have C++ 20 in our survey, so for C++ 17 group it's like no upgrade. But for others, you can see how the distribution actually looks like. And you can see that when people are closer to C++ 17, they are more willing to upgrade to C++ 17. Probably because that's like last step to do, so it's more like you don't need to jump like from C++ 98 to C++ 17, which might be just a groundbreaking change for you. It might be too complicated. But like if you're closer to that, especially if you're on C++ 14, that's kind of easier. And so there's quite a big amount, so more than 50% of these people are actually planning to upgrade to C++ 17. So we're not tracking this data for several years because we're all anonymized, so we can only see these slides for like this year. But that's a very interesting slide, so at least you can see where the people are planning to upgrade. I was actually a little bit surprised by still seeing some people trying to upgrade to C++ 03, but like, yeah, going from C++ 98, probably it's much easier to go to C++ 03 still, but that's not really big amount of these people. So there are quite many people on C++ 98 who actually are planning to upgrade to 14 and 11. And kind of very big group, I would say. Okay. Now let's talk about C++ per areas of development. So back in 2012, when we did a survey, we did a research on C++, we were trying to identify the major areas of development in terms of C++, because that's an obvious. When you start a new tool, you need to understand your market. You need to understand where you're going. So the biggest group is obviously financial, banking, and trading people. So this is the biggest group for C++. It takes like quite many, I guess, nearly 70% of what we got that time. So embedded games are following this financial group. These are also quite big groups in C++. And we'll try now to go through these groups and understand a little bit more about them. So banking and trading, so one of the biggest areas for C++. And I would say quite modern in terms of C++ usage. So maybe even in terms of C++, maybe even more modern than the others too. They still have quite a big language choices, so they have C++ for some very particular tasks. So there is Java for various big enterprise, backend, and trading platforms. There is C# for front-end and desktop applications. There is definitely Python and all other kind of scripting languages for doing various scripting. But C++ is still there for low latency and higher performance stuff, and they can't avoid it. And so it's a primary choice. And the thing that matters for them and why they choose the C++ is actually their performance. And their performance for them means not the quick throughput, but the low latency. And so if you go to any resource like Reddit or Stack Overflow and try to ask what to use for trading, what I should learn for doing trading or banking, you'll find quite a detailed threads explaining why you should use C++ if you're planning to do low latency stuff, and if you're playing something different, then you could use other languages. And there is a very good talk from CPPCon 2017 from Carl Cook. In the end of my presentation, I will have all the reference with the link, so if you're interested in something in particular, you can take a picture of that last slide and go by the link. So he was explaining the trading and the C++ and how it matters for trading and financial things. So the thing that I actually learned from Carl's talk, and which was confirmed by different people working in this area, so we have, like, to be honest, like we have the biggest group of our customers probably in trading and financial institutions, and we learn a lot from them, how they use the language, how they use the tooling, what they expect. So in terms of the latency, again, so that's not a quick throughput. That's why they're using actual C++ for low latency. And the tire deviation means more for them than the fast median. So you can be very quick 4 times out of 5, but if on the 5th time you're actually quite slow, you lose in this area. you're like a completely loser. You need to be really fast 5 times out of 5. And that's what the latency means for them. But they realized that like operation systems, networks, and hardware, the general purpose hardware and all this stuff, are actually focused on throughput and fairness, not on the like low-level stuff. So for them, there is a real challenge to understand what their compilers actually generate, and it's very important for them. And like no surprise, the most famous tool for understanding the compiler output, which is the compiler explorer, is coming from the guy who is working in trading. Like he was doing that every day. He finally created a tool to understand it better. That's what we're using now, and coming with this gut-bolting term. But it actually came, no surprise, from the financial industry. So they need to understand what is the compiler output. So what compiler is actually generating for them. They need to read this assembly and understand that. And so for these people, the C++ principle, don't pay for what you don't use, is a very important principle. And they actually keep it, and I see they very active in the committee when this principle is actually ready to be broken. They're coming there and they're saying no, because they understand that that will affect the latency factor for them. In terms of particular C++ usage, so these things are actually very good covered in the Perl's talk in very much details. So he's talking there about the importance of the allocation and how they reuse the memory, because these people prefer not to deallocate but to reuse the memory, like because it's much quicker than like deallocating and allocating back. You'd better reuse it if it's possible. They are very accurate with the template code. By many reasons, and especially by what is actually they get in the compiler output in the very end. They are more or less fine with the exceptions, but here is a controversial point for them. Some of them say that actually they are fine if it's not in the control flow, and especially if it's not thrown, then it's perfect. But I guess they will be more happy with static exceptions when they are out. So. And yeah, so they're working with the low-level C++ with the low-level CPU instructions. That's kind of obvious, because they need to control the output. And I would say that in this area, the huge companies are traditionally moving slower to the new standards by very actually obvious reason. Like if you remember the story with modulus, so how it actually went. So we had a modulus proposal in the very beginning, which was nil accepted. But then it turned out that it doesn't work. And who turned out, actually? That was Bloomberg, because they realized that that will affect the code of many users. And they just simply can't come to like 2,000 or 3,000 of users and say, like, we're changing this thing. That's impossible for this area, because this costs money, this costs like effort, there are many clients using, they're huge, the code bases are huge, so they're a little bit slower than others, but they keep track of what's going on in the language and keeping this kind of compatibility in the language so that they can move to the newer features less affecting their current code. And this is very important to them. Okay, the area which I'm a very big fan, this is the area where I was working for 8 years, this is embedded. And like, there were a couple of really nice talks here about the embedded at this conference. So talking about embedded here, I mostly mean not the hobbyist project, but the like big production embedded. And so if we, like when looking at this area, so we're currently very interested in this area because we're trying to move there with our tools. So we conducted a big survey and a big research on embedded. I plan to publish the results in some infographic form, probably later this year on our C-Line blog, because it's very interesting to me. So we were trying to understand how the actual area looks like. And the area is actually totally controlled by the MCU vendors. So you can't come to this area just with some tool you just create and saying, hey, I'm cool. That mostly won't work because there are MCUs, there are different types of boards, there are different vendors. And which is even more important, there are lots of certification and compliance tools. So for many errors, like if you're doing a self-driving car, no one will put it on an actual road if you're not passing the certain level of certification. And these certification and testing tools are very strict. They're provided by several companies. They're very expensive. And it's not that easy, like, for example, to move them to some new features or new standards. My former team where I worked for 3 years is currently working here in UK doing a self-driving track for Royal Mail. And they actually passed all the certification and told me about all this nightmare of passing this certification. That's really a nightmare because you can't just get a tool done by your own. And I know these are nice people who are kind of C++ geeks who are ready to create any tool they actually miss, but they can't because that doesn't help. They still need to pass some standard certification tools. So in terms of the language choice, they are quite often C, not C++. Many of them are trying to move to C++, and we see a very big effort in the community right now, thanks to many, many people there. So like if you take like Odin Holmes, who is doing matter programming in embedded, he's just amazing. There are many other people, and like meeting embedded last year, which was held for the first time, was a very nice representation of all these people who are actually trying to look at more C++ things in the area. But the problem is that since the market is controlled by the MCU vendors, there are many tools, libraries, and SDKs provided by these vendors. So if you want to move to the new standard, you first have to push them to move to the new standard in many areas. Or somehow to deal how you will be dealing with their like SDK or starter kit, still doing something different. That's usually a tricky task. So you sometimes are locked in the technologies, and which means you're locked in the language features in terms of the MCU vendor. But it's not that bad right now. So there are some nice libraries in C++, there are some nice movement, and so there are quite a lot of people around the world doing their hobby project on Arduino or other boards, moving C++ to that area, and after that they're coming to some more production level embedded with all this experience, which is moving at least the area closer to actual C++ tools. But how it looks right now, it's still a lot of C, and they're still emulating C++ classes with C with pointer to functions. So I on my own was like for 5 years do these awful structs with function pointers. And lots of macros everywhere because you get them in the documentation from the vendors, like all the registers, all the things are actually under these macros. And there is one funny story about the macros, why I hate macros in embedded. We once were doing a networking board for one company, which I couldn't name here because of some NDAs, but they had a chip from a very famous company providing some networking chips. And we were trying to understand why the Ethernet 5 board was not working at all until we, by their mistake, got their sources for the driver and found out that they had this nice macro called test Ethernet interface, Ethernet 5. We had no questions after that to their macros and why something is not working, because some things are just hidden behind these macros, and where you're just getting a binary, you can't get what's happening there inside. So the macro story is the very tough story for this area. We have lots of macros in embedded. Yes, Peter?
One comment. Most of the vendors, I'm not sure if it's deliberate or not, provide very, very bad examples full of macros, full of very, very doubtful software engineering practices, and that's all most of the electrical engineers from this country.
That's true. That's true, exactly. So Peter's comment was that the examples which are provided by the vendors of these documentation, they are full of macros. They're just some creepy examples, like how you can play with this macros, some creepy game, and get something blinking on your board in the very end. That's the thing we have to change there. So I see quite many people in the community right now who are trying to explain that you shouldn't do that. Use templates, use different things which we actually have in the modern C++ to make this more accurate and at least try to analyze, because these textual substitutions won't help you. Yes, Herb?
Some vendors are guilty of that, but also lately shipping tools to actually help you change your macros to context with them.
Yeah, actually, that's a very good feature which we could push on this area, like, yeah, change your macro to a const export. But like, yeah, the thing is that, as I said, the problem that we actually detected, the problem which we actually detected is that that's quite difficult to come to these people because they are really locked with the vendor. Because when you are, for example, coming for them and suggesting, hey, I have a cool idea, it will help you move your code from your old plain C to modern C++. They say, okay, but we have a board. And the vendor actually provided us this tool based on, mostly it's Eclipse plugin, sometimes it's Atom nowadays. But it doesn't matter. So it doesn't know really a lot about C or C++. Like C, okay, they're more or less fine. C++, they usually don't know anything, like they're just trying to parse it somehow. And they are not providing any smart features. But these people are very difficult to move to a new tool because they have a tool from the vendor. So the way we could work in this area is go into the vendors and explain them the value of our tools for their audience. And I think that's the only way that will actually work for this area. Okay, so enough with embedded. Let's move to a nice castle of games. So this is the third area. And this is the area which we actually dived in recently, trying to do more tools for game developers. So this is our ongoing work. And it was very interesting to look deeper into how they're using C++. So the language choices in the area are more or less straightforward. If you're an indie studio, you would like to start a game very quickly, just put a set of assets into one folder, shake it, and get a game, take Unity. C# Unity, you can build a nice game, you can actually sell it, you can earn money. Most of the market is actually doing that. If you want something more complicated, something more beautiful, interesting, catchy, you're coming to AAA, that's all C++. All AAA games are mostly on C++. And here we have Unreal Engine, the biggest player in terms of the more or less open engine to the world. So there is also Lumberyard from Amazon, which is actually the rebranded CryEngine thing. But it's I would say that right now it's far away from CryEngine. They've rewritten nearly everything from scratch. So, and the CryEngine itself, but most of the other engines, like the biggest percent of the engines in this area is some custom in-house engines. So we mostly don't know what they are using inside until they're coming to the conferences and actually telling us about what they're using. Some of them actually does that, but not all. And that's okay because these engines are usually cost a lot, and that's the main value for the company because they build games on this engine. And these are very big and tough engines on C++ with many techniques inside and many libraries built by the company. And so since it's AAA, we're usually talking about big game studios. But quite many of them are actually starting on Unreal Engine. I quite many times heard from these people, if you would like to start diving into AAA, you're just starting with some Unreal Engine. In a couple of years, when it's not enough, you're just creating your own engine. But Unreal Engine is a good example, and we'll dive into it a little bit deeper to trying to understand how it's using some language features and how it's missing some language features, because it's now open, so you can just register at Epic Games site, get the engine, and try and implement the game. You don't have to pay anything until you earn some money with your game. So they opened the engine several years ago to the world, and so you can now actually try to understand what they're doing there. So in terms of the rendering, there is a separate thing. So quite often the rendering is just in C, but that's probably fine. A very big question here is actually SDKs and various consoles SDKs which are provided in binaries, which means that if you have to move to a new standard, you first need to get a console SDK binary from the console vendor, which is not that easy. So if you are sitting in years 2019 and say, hey, I would like to move to C++ 17, the PlayStation people will tell you, what? They're not that fast, but they are moving actually. But you always have to take this into your mind that you can't just move on your own. You have to move with all these things as well. And again, so the performance here means latency, and that's very important for them. In terms of the usage, so many of them are still on C++03 and C++11. And there are reasons for that, because they actually don't see big value sometimes in the new standards, because they are waiting still for one big feature in the language. That's reflection. That's the most wanted feature by all game developers in C++. They need it. They're also not using Boost or STL because of the allocations, because they can't afford the standard allocation and they don't find the way of changing the allocation in the standard quite flexible. There is some quite often minimal template usage because they need a high compilation speed because they want to recompile and test the game quite quickly. But it depends, so some of them are quite nicely using the templates, and no exceptions, like they can't afford the cost. Digging a little bit more into reflections, so they use it for several purposes, one of which is serialization. And if it's just a regular serialization, then they should be fine with just a reflection, which means the introspection here. But if they're trying to generate some code, like in Python when serializing, then they need some code generation. And there are other purposes for reflection, like garbage collection, network replication stuff, and some various characteristics they add to the object, to the game objects. And how, for example, Unreal Engine is doing that, that's what I hate most about this engine, because that's macros. The whole reflection stuff in Unreal Engine is implemented in macros. If you come to the example here, you see this nice U class, U property, U function. There is also U enum macro. This is a macro which is there for reflection. When you want to reflect on your class, on your property, on your function, you have to add this. And it actually shows here a couple of characteristics, like in Unreal Engine there is C++ code and there is Blueprint code. And so this reflection often helps you to interact between these two. So like this class here, which is blueprintable, so available, extendable in the blueprint, and also some properties for working with these properties and functions in blueprint. The biggest haul of these macros is that if you take a look into how they implement it, they have line macro inside. And so this header, which is my object.generated.h here, this is the auto-generated header, which is created by Unreal Header Build tool, and it gets all the reflection information inside, so it actually aggregates it. And guess what? Line macro. Could you just think about what happens in the IDE when you try to type on the global level? Everything just got red immediately. And you actually have to run the Unreal Header Build tool, which is not that quick, so which regenerates the reflection stuff. So now you have the proper line numbers and you have the proper code resolve. That was a very nice challenge for us when we actually started doing that, so how at least to help people to avoid calling this thing. And there is also another very big case for usage of these things is like RPC methods. So like here I have a function with some reflection specifiers called server and with validation. So there are like remote procedure calls for like server client and multicast functions, and you just put this reflection specifier, and then the engine will be expecting that these two functions are implemented like implementation, so like the same name, server equip weapon, implementation, and since I have this reflection specifier with validation, it will be expecting the validate function. So, and you have to keep all these things in mind when you're doing your code. So what will be, what are you reflecting on, which functions you have to create, and all the text editors and IDEs are just getting mad with all this stuff because like here, if you're trying to navigate from server equipped weapon, you have to select where you have to navigate, and you have to explain to your IDE that actually you have to go to these two methods, which are completely not matched by the name because these are coming from reflection stuff. This is a very interesting world for IDEs. But the point is that these are very extensive usage of this reflection emulation. And every game engine is actually doing some kind of reflection. It's not always macros, so that's just how the Unreal Engine does that. But there are different implementations, but every C++ engine has some kind of reflection on board. Okay, let's step aside from reflection a little bit. I think I said enough about it to push everyone just to vote for reflection proposals. There are also custom allocations and custom STL, and the custom STL comes as a reason of the custom allocations. And there is a very good talks from CPPCon. One is from Nicolas Fleury, which is C++ and huge AAA games. These guys from Montreal, Ubisoft. He's just explaining how the Ubisoft is doing game development in C++. And the Scott Wardle talking about the memory in C++ debugging in electronic arts, and the very nice paper, of course, about the ESTL. Like, this is the STL they are using. Not all of them, like that, just most of them are creating their own STL, but that actually got some popularity in the games community. And there is this quote about this ESTL library that among game developers, the most fundamental weakness of STL is std allocators design, and is this weakness that was the largest contributing factor to the creation of ESTL. So, and that comes from the very simple fact they can't afford standard allocations. What they need to do is that they need to be more smart when they're allocating, so they need to avoid heap. Yes, Peter, sorry.
Just a question. When I teach SEO, the containers are just one part. The algorithms are much
Yes.
important. Do they use algorithms at all?
As far as I know, electronic arts are using the STL quite extensively in all the parts. I'm not sure about the others. Like Ubisoft doing these things differently. Like other companies which I talk to, they're doing different STL, not ESTL. So I'm just like, I was quite interested that they finally, like Electronic Arts, finally put something like more public, like trying to explain how they do the STL. So probably that, because we need to know about that, both algorithms and data representation. But the point here is that if we take a look and trying to understand why they're not using these standard containers and the standard allocators, so reasons here. So sometimes the lifetime is different. So what they do quite often is the allocators with the lifetime of the frame, because there are quite many objects that are not necessary after the frame has died, so after it's ended actually. They're trying to avoid heap, and this example is actually from Ubisoft talk. So this is the actual structure they're using. And so there's some data type they're using, and this is the default size. And that means that they have an object, like some static buffer of size A allocated. This is the typical size for this game object. And it's quite rarely more than 8, and then it will be relocated to heap. But that happens not often. And so having this customized size here is very important. So it's important for them to provide it to this container. Yes, so this was about the general STL function. So if you took a closer look at ESTL, it's actually much more than that. So it has some nice ways of explaining like what are the different containers, and there are some specific containers created by the especially game developers, so mostly interested for them. So there are some specific structures which are not available. So there is one part of ESTL which is matching to the standard STL, and there are some nice tables explaining how the containers are matched and different from what the STL, general STL is doing. And also there is some specific containers which created for some specific game needs, and it's very interesting to see how they look like and what's the general effort behind them. But again, let me stop with the allocators in games here. So let's jump to another topic which I promised in the very beginning. So let's see a little bit more infographics and try to understand how the people are actually, so when they're transitioning probably to C++, if they're using some tools to support them, some unit testing tools and some code analysis tools. So again, throwing a ball. So who does unit testing for most of the production code you write here? Okay. I like these hands like that. You know, I'm not sure. Like, yeah, Peter. So, but to be honest, like, here's none, not using anything. Like, last year it was 43%. This year it's much better, 25, but still quite many. Yes, Peter.
That is 25% of the community is not really professional developers.
Yeah, but they still call themselves professional full-time C++ developers. I'm also like very surprised with this results and disappointed with that results because like unit testing, like I'm not sure, maybe they are thinking that they're doing some, I don't know, regression tests and functional tests and they're not calling them unit tests. I hope for that at least, because like I would like to be safe when I'm using embedded device in the world. I would like them to do the unit testing. But still, there is a very interesting distribution of other frameworks. I cut the framework which are very slow in numbers, and under custom number in the very end, there are all these things like Qtest, XCTest, Juice, CTest, so they all fall under custom. And here you can see the most popular, so Google Test, Boost Test, CPP Unit, and Catch. Google Test, like kind of expected, very popular, it always was at this place. So I actually took a look at this question of like what are you using for unit testing. I took a look at the list in the Wikipedia. It's like more than 70 different testing frameworks for C++. If you just search for unit testing framework C++ in Wikipedia, there will be a huge list, like more than 70. So you have a huge choice here. If you go into Reddit discussions, I just listed a few of them here, which are mostly the biggest in the CPP subreddit. So there are like the people are asking questions like what to use there, and other people are trying to explain what to use. So if you more or less analyze the answers, you'll find out that like for the people are saying that Google Test with Google Mocks or Catch. It's more or less popular answer nowadays. Yes, Peter.
Tell everybody Google Test is crap.
I'm doing that quite constantly.
I looked at the code more than a decade ago. It's still the same underlying principle, and it's really not modern C++. It's C++ of 1995 and macros, and it's really not well done.
Yes, I won't be repeating all of that. I will just summarize that Peter is against Google Test here for the record. So, so in these Reddit threads, the people are mostly suggesting Google Test for serious big projects and Catch for your hobbyist project, or if you would like to try something new. So let's try to see why the people are actually selecting these frameworks and are they like good or bad or different? So Google Test and Boost Test are indeed quite feature-rich, maybe not that modern because like they are there in place for a quite long time. To me, the biggest issue with Google Test is that you can't easily start with it because it's not header-only library. So you actually, just to avoid any problems with binary compatibility, you actually have to put the whole Google Test library into your project and then compile it with your project, with all your flags. And you know, the most popular questions to us as we provide in our tools, the integration with the Google Test is usually how to add unit test to my project. I can't add Google Test to my project because we all have different project models and build systems in C++. There are plenty of them, and you have to find out a proper way of building Google Test with your project model, with your build system, add the library there with all the proper flags, compile it, and then gets your tests. Boost Test, they have the header-only opportunity, but since it's heavily templated, it actually slows down your build just like a nightmare. So if you really would like to go with the header-only way with the Boost Test, you can, that's possible, but it seems like no one actually does that because it's really slow in terms of compilation. Catch is very fine in that sense because you can just like write hash include catch.h and you're done. Like that's all you need to include the catch. That's actually quite cool. That's like kind of very flexible. But the people still like, I see that as here, you can see that the catch is actually growing, so from 8 to 12% this year. But I still see these answers on various Reddit threads that that's not for like serious projects. So maybe in a couple of years more, the people will realize that that's more appropriate. Or maybe we'll find something different. Yes?
I'm interested in the compile time because you've not answered that question. We've heard some people saying things, but when I tried Catch, I found it was quite slow, and I assumed it was the kind of header only and templating going on.
Yeah, I guess, the question about the cache completion speed, actually, I won't be answering it here. I will just redirect you to Phil Nash, the author of Catch, who's here. And you better ask him this question. I know that Catch point 2 version, the first version and the 2 version has the dramatical difference in compilation speed. So it's the version 2 is much better. Currently, it's version 2.7, I guess, or nearly 3 upcoming. I can assume that it's maybe even better. Maybe Phil knows something about performance measurements. I hope that he's maybe doing something like that. So yeah, he's here at the conference. Go to him directly and ask this question. He's the best person to answer about the catch. So yeah, but one more point about the unit testing. Embedded market. We did, as I said, the extensive research and the survey on the embedded market. And we were trying to figure out what are the unit testing tools people are using. This is not the certification tools, because most of them have to use some certification tools. But unit testing, what are you using? And the most popular answer, no, I don't use any. There is our research department is very keen on providing some lower and upper lower stuff. I don't care, the lower stuff is 84%. They're not using anything. On embedded, which is the crucial area where without unit testing, you might run into many issues which will be quite painful in runtime. But okay. And regarding the Rust, actually, all this Parasoft and Clockwork stuff, these are very expensive frameworks. So they're quite pricey. So Clockwork starts something like $25,000. Parasoft, depending on the edition and license, is from 3,000 to 2 and something millions. So these are some kind of expensive and professional unit testing frameworks for embedded. The thing here is, with embedded, there is some difference in how they run unit tests, actually. So there are some reasons for these numbers. So quite often, the unit testing which they're running on the hardware. So they need some framework working with the hardware nicely, or at least with their tools which are running some code in the hardware. And if you made something in-house, the people are not doing that, mostly because later they will still have to pass some certification, as I said, so they're not interested in that. And definitely they're quite lucky in the integration, because the things that exist now are just dozens of various plugins of different quality for Eclipse. And so they're all different in quality. So some of them are just fine, some of them are awful. I have a nice story here about this company I talked to you before, the team with which I worked previously, who are doing this self-driving car. So they actually doing quite nice integration into the IDE. So they are using C-Line, no surprise. I'm pushing them to the IDE. But yeah, the thing is that they actually run in some custom unit testing framework, which is doing the tests on the actual hardware. And they actually wrapped the whole output from this unit testing framework to look like the Google test output. And so they're just using the integration for Google tests and our tools, and they look at all the results of their unit testing framework in the IDE, but it's not the Google testing framework working there. That's nice. So not everyone actually does that, but that's a nice workaround, at least for the missing integration. Okay, code analysis and guideline enforcement. I actually started this question, so I took this question from C++ Foundation survey from last year, and I put it to this year survey. So I took all the answers that were used in the C++ Foundation survey, but just we just have another system of metrics, so we're not selecting some scores, some values for the answer, but just I'm using this or not, and you can select several options. So these are the answers. So which tool are you using for code analysis and guidelines enforcement in your code? There is answer none, like 1/3 of all respondents. There are very popular Clang Analyzer and Clang Tidy, like here. Some others, like CPP check, is still working quite nicely for many. Some others. And 42% of the respondents who told us that they are using the tool provided by their IDE. So, which is good or bad? Like, first of all, like if you integrate the tool, probably they will be using it, cool. If you don't integrate the tool, they won't be using anything probably. If their IDE is missing anything, so they will not use something for like forcing the guidelines. So for tool vendors to force guidelines on the like developers and help them with some code analysis, it's very important to integrate these things on board, because it seems that the people are mostly relying on these things. These results are also interesting because at my user group about 2 months ago, we discussed some questions concern regarding the code analysis tools, and like the people were presenting what they're using, what are the use case, which tools they like. And there was a huge discussion in the end because there were so many people in the room who told that they don't want their IDE to jump on them with these code analysis checks. What they want is they want their IDE to turn everything off, run all these checks on continuous integration server, and just send me the results once per week. Or better, once per month. I was like, come on. In a month, you will forget what you're doing in your code. And like, if, for example, the tool can help you, like all these nice modernized things, which, for example, Clang Tidy provides, the modernized checks, which help you to transition your code to a modern standard, like upgrade your for loops and binds to lambdas, all these things. They're not using them. They don't want them. And seems that like on CI, this check won't be helpful because you won't be coming to your code like 1 month from now or 1 week from now trying to change it. It's like no errors there, no potential breaks there, just the analyzer tool which is telling you that you could do better. You probably won't be doing that. On Friday evening, you'll go home and just close this. So, but I've heard this discussion that was very surprising to me. I was like, as I'm from the tooling people, I was trying to push them to the idea that it's much better when you see these checks instantly and you can apply the quick fixes or you can do something with it right here, right now. I was not very successful, to be honest. There were still many people in the audience who was for running this on CI only. Yes, Peter?
We will have the next decade a huge teaching opportunity. Because that's completely unprofessional. Every learning theory says feedback has to be as quick as possible. I even have, no, I didn't show it, don't show it tomorrow, but I have slides on that. Giving feedback is immediate.
Yeah, like as
it's important.
exactly.
If I hear stories like that, if I'm scared to actually go out of my house, all these cars and stuff with electronics everywhere.
Yeah, and 30% of the people not using any unit testing framework. I'm scared with you as well. So yeah, as Peter mentioned, so we have a huge learning opportunities here because we have to educate these people. And actually, I did one thing. I actually invited a person who will be doing a talk in a week from now about the code analysis and the importance of having it in the IDE. So I would like to push these people forward a little bit in this topic. But still, yeah, so these are the results. So in terms of the other tools, except from the IDE, like there's no surprise that the Clang tools are very popular because they're very strong now. They're maintained by the community. There are dozens of checks in these tools. Some maybe not that helpful, might be rotating, but you still can tune the settings. So you can just say like, I don't want this check because I have a reason for not having this check. And like, just show me the rest. So, yes, Peter.
Did you also ask who's actually using W-all, W-extra, and pedantic settings for the compilers? Because that goes, with modern compilers, it goes in that direction.
Yeah, the question was if we were asking about the like specific compiler options like pedantic in the compiler. No, we didn't ask, but that might be a good question to add for the next year. Thank you. By the way, if you're like you particular and all other people here are interested in some particular data from C++ community, you can just drop a question into me. I will do my best to add it. Like I unfortunately can't guarantee that I will add it 100% because I already failed with Herb. I'm really sorry. But I will do my best to push it forward and to add it to the final survey so that you can get the results when they're public. So okay, and now a very quick overview of what the language and the tooling parts can do here to help people a little bit. Just a few slides and just a few words I have in my mind. So there's no ball here, so just let's think together. So for me, in terms of the language evolution, like compatibility and the reduced cost of the integration of the new features is very important. So if we're providing a new feature, we probably should be checking that the integration costs are not that high. They are not zero totally, so there are no zero costs for integrating new features most of the time. But we at least should see if we can do it nicely, like I guess the recent Modelers case is the case when the people actually cared about this. And when I was looking for exceptions proposal by Herb, when I was reading through it, I was very happy to see like these ideas about how to match old code and new code, like how to match the dynamic exceptions and static exceptions, how to help people, like these people are throwing dynamic exceptions into me, what I should be doing with the static exceptions in my code. I think this is actually the most important part of the proposal. So because if we just drop the people like here, like use the static exceptions, they will still have some libraries with the dynamic exceptions, so they will still have to match. So these questions of more smooth integration of the new features into the currently existing code, into the legacy code, into the code that is using like some old style libraries, these questions are very important. So I think we should care about them a lot. And the other things are, the other part is about supporting in the tooling. So I do believe that the tooling is very important. So without the tooling, with the tooling, people could actually move much faster. But at the same time, they could be slower because the tooling doesn't help them, doesn't support them, or prevent them. So in terms of the tooling, like there are like one part is compilers who are adopting the new features. Obviously, without a compiler, your compiler adopted the feature, you can't do anything. But also there are IDEs who might help the people with the features. For that, the features have to be toolable, which is not always the effort that the committee takes into their mind when providing the feature, because sometimes supporting the language features might be a very heavy process for tooling. But luckily we have right now like tooling people in the committee. We have like tooling evolution group at least, and they can help and sometimes evaluate these proposals and to check if they can do better in terms of toolability for the new features. Like a very simple example of a very nice toolable feature is contracts. Like the contracts are fantastic. We have so big opportunities with them. We can just put these pre and post conditions into analyzer and check them in your code and show some result. This is nice. That could be very helpful. The people will be using the feature if they see this opportunity in the tool. I just want to show here a quick example of how the feature is actually working in the tooling and what the tooling can actually do here on a very simple example of templates. And templates, IntelliSense features, which quite not a very long time ago, I think just a year ago, it started to appear in some tools like Visual Studio. There were some feature in Peter's develop as well for templates. I'm not sure when it appeared actually. But for Visual Studio, for example, there is this, if the video can play, yes, so this is just the animation from the Visual Studio announcement when they announced the template in IntelliSense. And the idea of the feature is that you can go and just provide the type of which you will be instantiating the template in the UI. And then the Visual Studio will be using this type of information for future IntelliSense, like completion, for example. So we've added the type in the UI, and now the completion, will be showing the options based on this type information. So this is just a nice workaround. So if you have a template, you need to write the template body, but you need to know some information with actually what you will be using for instantiating this template. Okay, the obvious solution is just provide this information directly to the tool. Same feature, just as a quick example. So in ReSharper C++, we just went the other way. So we just took the, without any explicitly provided information in the UI. We just took the default types and used this information from the default types in like completion and parameter information. So you can actually help with this feature in many ways. So you can ask for the type explicitly. You can try some default types. You can actually do some more profound thing, which we're trying to do right now, is to analyze all the usages and to collect this information and to use it in IntelliSense. Yeah, that's just the next step. But I just wanted to show you with this that for modern features, there are plenty of improvements we can make in the tool and we can help. And that's what we have to do to help people to use these features, because using the template body without any kind of completion could be quite difficult, especially if you're just instantiated with a couple of types through the whole code base. So you more or less know with what you will be instantiating it actually quite often, so most of the times I would say. So yeah, that was just a small example on how the tooling can help. And that's mostly it. I will stop on this slide so that you can actually take all these links that I was referring to. So there is the Foundation survey, the JetBrains survey. So for 2019, the year, the results are not available, but they will be by that link. For previous years, they are already available. There is also these old infographics. It's written collected in 2014. That's not true. It's collected in 12 and 14. And also these talks from CPPCon, which I was mentioning in my talk here. And so that's it from me here. Thank you, and I'm ready to take the questions. Yes. Which group? Front-end. So I can't mention any projects here because that's just the statistic data. So we have the issue here is that we have the same set of areas for each language. So just because we match some results through the languages without the language distribution. So we have this question about in which area you're doing your professional development, and it includes this front ends and all the options. So I don't know which projects are there in particular for C++. I just see some answers for this area from the respondents. So I can't ask these people because the data is anonymized. So yeah, my preference would be to change this question a little bit. Maybe I will tune it for the next year because I would like to have a little bit different set of areas there. But the reason that sometimes these areas might look strange in terms of C++ is that because we have the same set for all technologies, and this is important for us to make cross-language analysis, to see which area is trending for all of them, not only for particular C++ slide. Yeah, thank you. Yes, sir.
Just a suggestion. I noticed that you went by each standard that was released, but C++ 03 contained 0 features. It was a standard
yes.
Only, it was a patch. In fact, it was retroactive, so basically any C++ 98 implementation needed to be C++ 03. So really those two are the same thing. You might consider combining them, because anyone who responded distinctly to the two was probably confused.
Dreaming about something else, yeah. Yeah.
And maybe they were following what was on their compiler's packaging, which was correct, but they're one bucket.
Yeah, so the command from her was that we could actually join the C++ 98 and C++ 03 bucket here in the story because that doesn't make sense to divide them. That's actually true. So yeah, probably next year I will add one more standard and we'll join these two.
But I understand why you kept them separate, because once you do the survey, you want to keep doing the survey the same way, so you can...
Yeah, exactly. Yeah, so that's true. We're trying to keep the same set of answers, only adding something new to keep the track. But I think that will be more or less fine. So we just have to reevaluate some data later. And since in research is done automatically, that's not me calculating the results. So all these weighted algorithms, they're working automatically. So I think the people can reevaluate. Yeah.
My suggestion was keep the question the same, but when you aggregate the results, combine those two values.
Yeah, I think that maybe it will even make some sense to just aggregate the options here and just leave the people with that doubled option. Yeah, thank you. Yes?
I found it quite hard to answer some of the questions because in most of them the answer was yes. Because if I'm working on the support of that version, then I'm using that version as a compiler with that version as a standard. If
I'm using that one, I'm using this one. Well, it should have been today, but then we can start moving up to C++ 14. Well, yes, but and with the tooling and the suggestions, if I'm looking at code where I don't want this version to diverge from that, just because I'm looking in 2017, I don't want all these put in autos, because I can't use autos, because it's got portables after that. So I really need to switch my settings, depending on which bit of code I'm looking at, why. Yes, I know ReSharper can do it, but I can't drive it properly yet.
Yeah, actually, I would add to this command that when I was analyzing the data, I just realized that we're asking like non-exclusive answer to the question of the standard, so the people can mark several standards. And that makes it hard sometimes to analyze and to make like some actual results out of that, some actual infographics, because yeah, sometimes they're like selecting, not all of them, but like several in a row, several consequent standards. So when I was trying to build the infographics here, I was using the highest possible standard they marked actually, which may be not accurate, you're right, because maybe they're like doing a few projects at work on C++ 17 and all of the rest are at C++ 11, that's also true. I don't see the good way to dig with it into current data, so we probably could limit to one standard, but then I think the people will be a little bit more surprised because sometimes they're really using several. So that's a good question, and that's a question for us to think about how to maybe do this survey a little bit more accurate in terms of what we would like to achieve. So we could just think about some additional questions here. So yeah. Maybe providing some direct transition spots and asking some questions in that sense. But yeah, thank you. You are actually right. I was thinking about that when collecting the data. Yeah, welcome. Okay, more questions? Okay, then thank you for coming here. Thank you.